afternoon, Algebra 1. How are you today? Periods 1, 6, and 7. It's Tuesday already. It's the 28th of April. May is almost here. Spring is coming. The sun is shining. The trees are getting green. So is the grass. And it's just great. So anyway, coming to you from room 308 today. And I've got a couple examples for you. You may have noticed that I posted your 9.2 and 9.3 assignments out there. I attached the answers for 9.2, and I've got them for 9.3. I'll stick those out in a couple days, maybe tomorrow. And also, I put two worksheets out there. They're working with radicals. One of them's called Simplify, and one of them's called Multiply. So what I did, I took two problems off the Simplify sheet, and I would like to explain them because it's been a while since you guys have had an opportunity to do radicals. So this is what it might look like. Okay, so here it is. Algebra 1, adding and subtracting radicals. Here we get to add and subtract radicals. So problem number 1 looks sort of like that. It says 3 square roots of 8 plus 5 square roots of 8. Now, two things. Thing 1. Both of those have the same root, the square root of 8. I have 3 square roots of 8, and I have 5 more just like it, 5 square roots of 8. So I can add those two together and call it 8 square roots of 8, okay? Now, if the square root of 8 was not simplifiable, cool word, huh? Then we would be done. However, the square root of 8, 8 has a square factor. Thing 2, which says that the square root of 8 is equal to the square root of the product 4 times 2, which is the same thing as the square root of 4 times the square root of 2. And we all know that the positive root, we're only dealing with positive roots here, that the square root of 4 is 2, and the square root of 2, you just leave it alone. Okay, so the square root of 8 is 2 square roots of 2. Now we had 8 of those things, right? So we have 8 of those. So now it looks like this. 8 times 2 square roots of 2 is equal to 16 square roots of 2. So when it says to clean this mess up, this is what you're going to do. You're going to add your like terms. And those are like terms. They're both square roots of 8. You got 3 of them, you got 5 more. So you got 8 of them. Okay? Now, number 5. Oh my goodness, isn't that ugly? So I labeled it, that's ugly. Okay? Now, ugly looks like negative 2 times the square root of 54 plus 3 times the square root of 18 minus 2 times the square root of 6. Now, the good news is that 2 square roots of 6, you can't do anything with it. There are no square factors in 6. So that piece on the end, it's done. However, 54 and 18, knowing your multiplication tables, you know that 9 times 6 is 54, and 9 times 2 is 18. Therefore, and 9 is a square. So 54 is going to look like that. This negative 2 times the square root of 9 times 6. And 3 square roots of 18 is going to look like 3 times the square root of 9 times 2. And then, of course, negative 2 square roots of 6. Now, we know that I can take that square root of 9 times 6 and break it into the square root of 9 times the square root of 6. The square root of 9 times 2. I can break that into the square root of 9 times the square root of 2 minus, negative 2 square roots of 6. Now, last I looked, the square root of 9 was 3. Okay? So, negative 2 times 3 square root of 6 plus 3 times 3 square root of 2 minus 2 square roots of 6. Still hanging on. Now let's clean it up. Negative 6 square roots of 6 plus 9 square roots of 2 minus 2 square roots of 6. Now notice the square roots of 6, those are both the same thing. I got negative 6 of them, and I'm going to take 2 more away. So I can combine the square root of 6's. And when I do that, I get negative 8 square root of 6 plus 9 square roots of 2. Okay? So that's a little review on radicals. And then the next thing I'd like to do, I would like to look at number 32 from 9.2. Okay? Now it says use the method from example 3 or something like that. And all they're trying to get you to do is realize that I can take that equation, if I put the squared element on one side and the linear term on the other, I can graph the two by setting the left quadratic y is equal to x squared. And then I can take the right side, the linear component, and I can say that y is equal to 6x minus 5. Now, if I graph those on the same grid, you will find a point of intersection. So this is what I did. I punched it up into GeoGebra, and I'm going to clean this board up. And I'm going to put it up here for you. Are you dizzy yet? All right, so this is what we got. It looks like that, okay? So when you graph those two lines, well, those two functions, then you see the parabola, the parent, that's the parent, and I did have to stretch the graph out to get the, the 25 on there. But you will notice the line y is equal to 6x minus 5 crosses the y-axis at negative 5 and has a slope of 6. Ta-da! And there's the parent, the parabola, y is equal to x squared. That line intersects that parabola when x is equal to 1 and when x is equal to 5. Okay, that's what they're trying to get you to do. All right? Now, we do this for a couple different reasons. This is kind of going to lead us into some explorations down the road on quadratics versus a linear and different components and how you can actually dissect different functions into their components and actually find cool things. So they're going to start out with the simplest, the quadratic, and they're going to go from there. But that's what they want you to do on that, okay? Okay, so 9.2 and 9.3, let's get those done. Let's wrap those up for Friday. I put those couple worksheets out there. One of those worksheets is due on Friday. One of them's not due until next week sometime. And then I'd like to move to 9.4 and 9.5, 9.6. You see where this is going. And then move into chapter 10. By the end of next week, I would love to be just about done with chapter 9, starting to look at chapter 10 a little bit. So can we get to use the quadratic formula? Next, we're going to start solving things using the square root method. That's kind of a neat thing. And then we're going to move into vertex form and completing the square and some other really cool stuff. Okay? Anyway, remember, bottom line is I got to get you guys to be able to use, master, derive the quadratic formula. All right, that's kind of our game plan, folks. So that's what you get to do, and have fun doing it. All right, May's out.